So last class, at which particular instant we stopped? Which particular
Energy of
concept?
oscillation.
Energy of oscillations. Okay. So have we done equation of a particle starting from mean and starting from extreme? We have done that. What was the equation we got? X is equal to A sin omega t for a particle starting from mean position, and X is equal to A cos omega t starting from extreme. Okay. Now we'll do one small topic and then I'll come back to the main topic. So write down the side heading. Time period of a simple pendulum. Write down side heading. Time period of a simple pendulum. T is equal to 2 pi under root L by G. This is the formula for time period of a simple pendulum. Right.
Sir, it's used in only oscillation or every lesson?
Simple pendulum. That means oscillation. That only, not only in oscillation, only for simple pendulum. That means if it is only oscillation and not simple pendulum, also we cannot use this formula. Do you understand? This formula is specific to only simple pendulum.
Okay.
Now, can you tell me the SI unit of time period of a simple pendulum?
Seconds.
It will be second, without doubt. Now tell me, what does L stand for and what does G stand for? L stands for length of the pendulum. Correct?
G is for gravitational.
Acceleration due to gravity.
Yes.
G stands for acceleration due to gravity. G stands for acceleration due to gravity. Clear? T is equal to 2 pi root of L by G second, where L is the length of the pendulum and G is acceleration due to gravity. Okay. Tell okay.
Yes, sir.
Now, properties of simple pendulum. Very easy topic. See here. What is the formula for time period of a simple pendulum? Formula for time period of a simple pendulum is 2 pi under root L by G. Length till the center of the bob. Right, till the center of that bob. Now, tell me, what does time period depend upon? Some 2 or 3 things, or 2 things time period depends upon. Can you tell me? What does time period depend upon? Looking at the formula, what does it depend
Sir,
upon?
Square root of
length
length
of
of the pendulum.
Can I say time period is directly proportional to square root of length?
yes,
And
sir.
can I also say time period is inversely proportional to acceleration due to gravity? Looking at the formula. Also, once look at the screen. Also, can I say that time period is
Mass of the bulb.
Independent of mass. Why? Because it is not there in the formula. I'll tell you why this point is important. Because in olden days, people thought if I make a pendulum out of rock or if I make a pendulum out of paper, they thought rock being heavier will take time and paper, since it is very light, will oscillate faster. But actual answer is you take pendulum, it does not depend on the mass. That means I can make pendulum out of any substance. My time period won't be affected. Also, in the exam, they'll ask you, time period of a wooden pendulum is so much. Now, wood is replaced by steel whose mass is so and so. What is the answer? Answer is same. Time period does not depend on mass. Also, they'll ask you one more thing. Time period of a simple pendulum is this. Now, the material of the pendulum is made lighter by adding some wood or adding some alloy. Now, what is the improved time period? Answer is nothing. Time period will remain the same because time period does not depend on the mass of a pendulum. If the mass is increased or if the mass is decreased, this is, remember, this is only for time period of pendulum, okay, not general time period. Okay, remember, all this we are doing is only for time period of pendulum. Therefore, for your exam, if they ask you what are the three properties or what does time period depend on or what does time period does not depend on, I can say time period depends on square root of length. Time period inversely depends on acceleration due to gravity, root of, and time period is independent of mass. So can I say these are the three properties of time period of simple pendulum? Correct? Make a note quick. Properties of simple pendulum, property 1, property 2, property 3. Property 1, property 2, property 3. Correct. He had also demonstrated one big ball of oscillation.
He sat on it.
That was my college in masters, same college. Now listen. What is the formula for time period of a simple pendulum? The formula for time period of a simple pendulum is T is equal to 2 pi under root L by G. Understood this much? This is in second. Now, if I ask you what are the properties of time period of simple pendulum, you will tell me there are three properties. First thing is time period is directly proportional to square root of length. Second property is time period is inversely proportional to acceleration due to gravity, square root. And the third property is it is independent of the mass. It is independent of the mass. Clear? Now you will say it is independent of volume also, it is independent of density also because nothing is there. No, I'm telling you why, because people thought it depends, but actually it does not depend. That is why I brought in mass. Actually, whatever is not there in the formula, it does not depend. I agree. Now, if you say instead of mass, can I write surface tension? No, you cannot write. Why I'm giving this point is because people thought in olden days that time period depends on mass. Actually, it does not depend on mass. Okay, just like love. Love does not depend on mass. Okay, now can we go to the next topic? So now when I ask you the viva, you should know everything. You should know the time period of a simple pendulum. You should know the properties of simple pendulum. And the next topic is seconds pendulum.
Can you go to the previous slide once? Okay, sir, done.
Seconds pendulum. Listen. I'll give you time to write. I will give you time to write this. A simple pendulum which takes 2 seconds. Second. which takes 2 seconds for oscillation, is called a seconds pendulum. 1 second for to, 1 second for fro. You know that oscillation is called to and fro motion. Therefore, it takes 1 second for to, another second for fro. Such kind of simple pendulum whose time period is 2 seconds, that type of simple pendulum is called seconds pendulum. Now you'll ask me, what is the difference between seconds pendulum and simple pendulum? Answer is, seconds pendulum is a special case of simple pendulum. It is simple pendulum itself, but it is a special case of simple pendulum. What is this special case? The special case is the time period is 2 seconds. The special case is the time period is 2 seconds of a simple pendulum. That simple pendulum is called seconds pendulum. My question to you is, can you derive the formula for, okay, come back. Copy this. This is your definition of seconds pendulum. A simple pendulum whose time period is 2 seconds is called a seconds pendulum. Okay, done. Now my question to you is, what is the formula for length of a seconds pendulum? Can you derive it and give me the answer? What is the formula for length of a seconds pendulum? I'll be back in 2 minutes. Okay, I'll just get my tea and come. I have the phone with me. You can give me the answer if you get. I'm just going to the kitchen. Okay, I got some answers for length of a second's pendulum. Now listen to this answer. Length of a second's pendulum. Correct. I'm getting the answer. So can I say my general formula for time period is T is equal to 2 pi under root L by G. Can I say for seconds pendulum T is 2? Correct, because we have decided that time period of this is 2. Therefore, can I say 2 is equal to 2 pi under root L by G? 2 and 2 cancels. Therefore, 1 is equal to pi under root L by G. Square both sides. So 1 will be equal to pi square L by G. L will be equal to G by pi square. Getting this answer?
Yes,
Can
sir.
Yes,
everyone-
sir.
Can anyone tell me something more about this?
Sir, approximately equal to 1 आएगा value.
Correct. Approximately equal to 1. Approximately equal to 1. 0.99, but approximately equal to 1. Therefore, can I say length of a second's pendulum is approximately equal to 1 meter? Therefore, listen to me. In any question in the exam, if length is given as 1 meter of a pendulum, can I automatically conclude time period is 2 seconds? Or if in the question, no problem, no problem. If in the question, if they give time equal to 2 seconds, can I automatically conclude that length is 1 meter? Therefore, this is like a dual sim question. They will give only one data, but you should understand two things. If they give you time 2 seconds, you should understand 2 seconds, 1 meter. Or if they give you length 1 meter, you should understand 1 meter, 2 seconds. Did you understand this indirect meaning? So sometimes you will feel that the data is not sufficient, but data is sufficient because from one data you have to get two data. That means from t equal to 2 seconds, we should also get L equal to 1 meter. That they won't give you in the question. Understood? Therefore, now we finish 3 topics. First topic, listen to it. What is the formula for time period of a second's pendulum? What is the answer? Sorry, simple pendulum. T equal to 2 pi under root L by G. Then what are the 3 properties of second's pendulum? Sorry, simple pendulum. The 3 properties of simple pendulum, it is directly proportional to square root of length. It is inversely proportional to square root of gravity, and it is independent of mass. Then what did we do? We did seconds pendulum. What is a seconds pendulum? A simple pendulum whose time period is 2 seconds is called as seconds pendulum. And then we did what is the length of a seconds pendulum. Therefore, in my Viva, if I ask you, give me the formula for seconds pendulum, you cannot tell 1 meter. You have to give me the answer G by pi square. That is the formula for length of seconds pendulum. But if I tell you, give me the value for length of a seconds pendulum, then you'll tell me the value is 1 meter. Therefore, you'll tell me the value is 1 meter. Is it clear?
Yes, sir.
Sir, so 1 meter is equal to 2 seconds, na?
1 meter equal to 2 seconds only for pendulum. In some other chapter, you say, sir, I told 1 meter 2 seconds. No, only for simple pendulum.
Second
Okay, please remember. Okay.
Yes, miss. Yes, sir.
Okay. Now what I'll do is, now this is easy, right? What is it? Pendulum happily going left to right, right to left. No challenge in simple pendulum. Now I'll tell you when the challenge will come. Challenge will come when you take a simple pendulum inside a lift. That means I'll combine many concepts together. Now I will take a simple pendulum inside the lift. Okay, very nice. Very good lift. Tell me your favorite brand of lift. Answer is we don't know. But I have my one favorite brand of lift. Everyone switch on your camera. I want to see your beautiful faces. Only then Shari will come out. Correct? Yes.
Starting from X.
Starting from S. Schneider. Yes, Schneider. Schneider is there. Correct. Schneider is there. Otis is there. But my favorite type of lift is old Jamana ka lift. You have 2 black grills. And if you don't close the grill properly, music will not stop. Okay.
Yes, sir, I have in my building.
Yes. And
In my
many
building.
times you switch it off or many times you close the grill, lift does not start because you have not closed either the outer gate or the inner gate properly. Then with
Yes.
full khunnas again you hit it, chatak. Then the lift closes and then the lift starts. In modern lift, you cannot do that attack. We cannot throw khunnas on modern lift because all are touch screen buttons, correct? That is why in previous days, when landline was there, landline, when you are angry with
Yes.
someone, and you smash the phone down, you get good satisfaction, correct? Full smash the phone down and they also hear chut sound. Here, if you're angry with someone, You are standing in the middle of the road, switching it off. Okay, your full anger will go. You cannot drop the phone. You have to just click the button or you have to swipe it off. So olden days was very good. Olden days lift. Have you seen black color buttons, music, and fan was a silver stick coming up and down. Have you seen that? That is also oscillation, correct?
Different
Okay.
things to bang.
You still have that lift?
Yes, sir.
Yes, I like that lift. I like that lift. Correct. Then between the two floors, people write something on the wall also. Have you written with sketch pen? No. Yes.
Yes,
Very
sir.
nice.
I have
Yeah. Okay. Very good. Okay. Now, if I take pendulum to the left, and I will tell you case one. Okay. Now listen to this. Now I have taken a pendulum inside the lift. Whenever you take pendulum inside the lift in Mumbai, people will look at you like, "Koi kaam nahi hai." Okay. Like, this is hypothetically. Now I have taken the pendulum inside the lift and the lift is at rest. Means the lift is not going. Okay. That means the time period will be unchanged. Can I say time period will be the same? So tell me, what is the time period of a simple pendulum in a lift when the lift is at rest? Can I say it will be 2 pi under root L by G itself? Because lift is not moving up, lift is not moving down, lift is at rest. Clear? Okay, make a note. Lift, special case of simple pendulum, or lift and simple pendulum.
Sir,
If you
this
go to
can be for any moving body up and down or only for lift? Like,
correct. Any body moving up and down is actually called a lift. In India, we call only lift where we go up and down. Otherwise, any body moving up and down is called a lift. And in India, we have a wrong thing that we take lift from people on the road, correct? Taking lift from people on the road means going up or going down, but we are going horizontal.
Sir, Indians can do anything.
Indians can. There is only one thing Indians cannot do, that is stop watching cricket.
So what? Stop watching?
Cricket. So it is basically for accelerating bodies, correct? Accelerating is a key word in this. We'll go. I want to check how good your other part 1 of physics is in this chapter. It is indirectly I'm checking your part 1 physics. Okay. Understood? Special case 1, T is equal to 2 pi root L by G. Pendulum is happy. Now imagine now. Look at me. Imagine now. Lift is going up. Very good. With constant velocity. Lift is going up with constant velocity. Then also my time period won't change because velocity is constant. Therefore, my formula remains unchanged. Right now. And Lavnish, you're looking like Spider-Man on the screen. Now you're looking, yes, perfect. Far from home, away from home, no way home. Yes, correct, good. Now, when the lift is going up with constant velocity, can I say that formula for time period won't change itself? It is T is equal to 2 pi under root L by G. Correct, Lavnish? Now, can anyone tell me if you have got it? If you have got it, can you tell me this case? If the lift is going down with constant velocity. If the lift is going down with constant velocity.
G plus V.
sir, same ही रहेगा ना time period.
Correct. Who told me this answer? Who told me this answer?
Nikhil.
Theron. Yes, correct. It will be
No,
same.
no, sir. Nikhil.
Nikhil, correct. If it goes up or if it goes down, if velocity is constant, time period won't change. Therefore, can I say even if it is going down with constant velocity, my formula will be T is equal to 2 pi root L by G itself. Understood? Therefore, I have given you 3 cases in a lift where the answer does not change. Now, my next 3 cases, my answers will change. Okay, in my next 3 cases, my answers will change. Till now, lift is not troubling the. Yes, it is linear, correct. Otherwise, it would be omega, angular, correct. Otherwise, we are taking vertically upward and vertically downward. That is why. Otherwise, if you take angular, then definitely change. We have taken 3 cases of a lift. One is at rest, one is going upward with constant velocity, and one is it is going downward with constant velocity. And time period is 2 pi under root L by G, 2 pi under root L by G, 2 pi under root L by G. Is it clear?
Yes, sir.
Now, when the lift is moving upward, listen, when the lift is moving upward with, okay, let me come there. Let me come to that page. Okay, I'll write it here only because it's already a mess. When the lift is moving upward with constant acceleration, okay? Now, velocity is not constant, acceleration is constant. Can I say when the lift is going up, once look at the screen, can I say G will be equal to G plus A? Any body going upwards, G can be written as G plus A. Therefore, tell me what will be the time period of my pendulum. Can I say it will become equal to 2 pi under root L by G plus A?
Yes,
Clear?
sir.
Yes, sir.
But remember, this is with constant acceleration. Now, don't get in a problem. You have to see the word velocity, you have to see the word acceleration, and then you have to proceed. If it is constant velocity, there is no problem at all. With constant acceleration, you have to see whether it is going up or whether it's going down. When a body is going up, you might have studied in some other chapter of part 1 that effective acceleration due to gravity is G plus A. Now, can anyone tell me the next case? The case also plus the formula. So anyone?
Sir, when the lift is going down with acceleration.
Yes, when the lift
acceleration.
is going downwards with constant acceleration, that is the next case. And what is the formula?
Sir,
Minus
T
A.
equal to 2 pi root L by G minus A.
Perfect. Under root L by G minus A. Easy. So write down. That is the next case. When the lift, you have to write down in full form, okay? When the lift is going downward with constant acceleration. That is why I'm giving you time. When the lift is going downward with constant acceleration, T is equal to 2 pi under root L by G minus A. So case 1, 2, 3, 4, 5, all 5 cases done. Now the sixth case, let me tell you. First finish it. Okay, finish.
Sir, what if the acceleration
Now, the last case, case 5 is, what if the body, yeah, Samar, you're saying something about some special case. Samar, you're saying something? Yeah, tell us. Samar, you're saying something. I'm waiting for a question.
Yes, sir. Sir, what if the constant acceleration, which is downward, sir, it is equal to the acceleration due to gravity?
Yes, that is the last case, correct. So that when does that happen? Tell me, when does A become equal to G for a free falling body, correct? For a
Yes,
freely
sir.
falling body, you know, the person feels weightless, correct? A person feels weightless only in two situations, in love, and one is freely falling. Now, when the person is freely falling in the lift, that means the rope of the lift is cut. Now, if they say the rope of the lift is cut, lift is still not falling down because lift is already in the ground floor. Okay, they will not give you that. But if they say the rope is cut and the lift is falling down, can I say this becomes a case of free fall? And
Yes,
in
sir.
free fall, can I say that condition will come under lift going downwards only?
Yes,
And,
sir.
but inside the lift, people will go upwards if you think about it. Okay, but that is separate. That is separate. We are only bothered about pendulum. What happens to you does not matter. What happens to the pendulum, you have to see. That means anytime in future, if the lift is cut and everyone is falling, you have to just look at the pendulum. Okay. That is. Now listen. If the body falls freely, A will be equal to G, correct? A will be equal to G. And in that is my next case actually. If A becomes equal to G, can I say my time period becomes infinite? Because denominator becomes G minus G. And if denominator becomes G minus G, denominator becomes 0. If denominator is 0, numerator
Infinite.
becomes infinite, correct?
Yes.
What is the actual meaning of the word infinite? Time is infinite means it will not oscillate. For example, if I tell you, I will take infinite time to come to your house, that means I'm not coming to your house. Means I will not reach your house because it is infinite time. And if I reach your house, then it is finite time. Do you understand? That means, what does it mean when time period equal to infinity? Mathematically, I got it equal to infinity. But what does it actually mean? It means the pendulum will not oscillate. That is why in a satellite, pendulum does not oscillate. Do you understand now why? In a satellite, pendulum does not oscillate. In outer space, if I want to keep a wall clock with pendulum, it will not oscillate.
Because
What
there
you
is
have
no
to do?
gravitation.
No
Yes,
gravity.
correct. Then you have to ask Elon Musk to solve that problem. Elon Musk will solve that problem. Okay,
Okay.
Understood last case. Also, in that case, if they say a pendulum clock was working very good on Earth, on space it is not working. The first question is, why did you take it to space? Okay, why did you take it? Okay. Second question, maybe it is made in China. Third question, answer is this, where G equal to A, where G is equal to A, or A equal to G. Or write down as case 6, free falling lift. And free falling lift means free falling body, okay? And that happens only when the rope is cut of a lift. On a serious note, if a lift is freely falling, you have to lie down horizontally on the floor. Okay, you have to lie down horizontally on the floor.
Spread
But
legs,
in
sir.
which one?
Spread hands and legs, na?
Yeah, but the problem is in India, in Mumbai, people will be there in the lift with us. If you go to sleep nicely, spreading your arms and legs before the lift will kill you, people will kill you in the lift. Okay, so you have to stand there in the lift. Correct. So that is the problem.
Sir, but what happens if we spread our hands and legs?
See, actually, right, when the lift goes down, you go up because the speed of the lift is down. So you get pushed up. So when you get pushed up, you should make sure your head does not hit on the top. Your back is strong, correct? So you should make sure that you lie downwards and let your back hit the floor. And once the lift comes to stop, you'll fall down. So your hand will take the hit. Means you'll get fractures. But otherwise, it looks very silly. But otherwise, even if a lift breaks from 4th or 5th floor, a person dies inside the lift. Very difficult to survive a lift accident. Very difficult to survive. That is why all modern lifts have compressor systems. If you have seen, down springs are kept, correct? Also, more than 3
Yes.
cables are kept, especially with the lift which are steel doors, the modern lifts. So even if one rope breaks,
Yes, sir, I see.
there are 3 ropes. Even if one rope breaks, the lift will not work. Means there are 3 ropes. That means you have to repair that rope, only then the lift will work. You know, nowadays modern cars, until you wear the seat belt, the sound will keep coming. And if you take even ultra modern luxury cars, if you don't wear the speed belt, even after 1 kilometer, the car automatically stops, means ignition stops. The car won't go ahead, means you cannot go without a seat belt. Okay, so all nowadays we have modern safety systems. I have a very good story about the lift and safety system, which I do it in my building. That I'll tell you after the class. Remind me, okay, once after the class.
Okay, sir.
Now, can I do a summary of all the cases? 1 minute. I had a JEE class right now in some other class. There I had done it. 1 minute, okay? Let me see if I have that summary page with me. We were doing oscillation questions itself. Yes, this is the summary page. This is from H.C. Verma. This page. Tell me if you have understood all 6 cases. Check. Can you make a summary page like this and let me know? Can you do it on your own? Instead of me asking you, Viva, can you do it on your own and tell me whether all the cases are clear of a simple pendulum in a lift? We have covered all the cases of a lift. We have covered vertical and horizontal. We have covered upward and downward. Okay, vertical and horizontal is different. We have done upward and downward. Okay.
Yes, sir.
Yes.
Okay, done. Okay, now listen. We have done the cases. Now comes the next topic, which is the graphical representation, which is a very, very important topic. Till what time is our class today?
7.
I think I can complete that topic before 7 itself. That is the topic which we have to do, the final topic, before we do the module. Does everyone have the module now of SHM with you? Have it, right? Okay. Now, before I do that topic, I'll do one small topic. I think I can do this. Now listen to this. This might not come that much in JEE, but it comes a lot in MHT-CET. Anyway, you will answer MHT-CET also. Now listen to me. You know spring constant K, correct? F is equal to minus Kx. Now like that, if many systems are connected in series, for example, look at the screen. I have K1, K2, K3, a lot of systems connected in series. Then my equivalent constant is given by this formula. 1 by Ks is equal to 1 by K1 plus 1 by K2. Does it look familiar to some other formula?
Circuits connected
Resistance in
Resistance in parallel. Can I say it looks similar to resistance in parallel? Because resistance in parallel, we had a formula 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by dot dot dot. Here it is springs in series or systems in series. For example, in a problem, if I have more than one spring constant, or if I have more than one force constant, what is my equivalent force constant? I cannot take one or the other, or I cannot take average. The formula is when they're connected in series like this, then I have to find equivalent constant, which is given by this formula, which is same as resistance in parallel. So make a note of this. Make a note of this. Okay. Now, can you predict, looking at this formula, can you predict what will be the formula for force constant when they're connected in parallel? Can you predict?
Sir, Kp will be equal to K1 plus K2 in Kn.
Correct. It will be same as resistance in series. Can I say springs in series is similar to resistance in parallel? Therefore, can I say springs in parallel will be similar to resistance in series? Look at the formula. So can I say Kp? Can I say exactly ulta? Therefore, can I say equivalent spring constant when they're connected in parallel will be Kp equal to K1 plus K2 plus dot dot dot. Therefore, make a note of these two formulae. Important from your boards plus MHT-CET point of view. So the equivalent force constant when they're connected in parallel, K1, K2, K3, where Kp is equal to K1 plus K2 plus dot 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 Kn.
सर फॉर व्हाट मतलब किस चीज के लिए अरेंजमेंट होता है फोर्स?
For which किस चीज के लिए after that?
मतलब why do we arrange forces like this?
Okay, for example, they'll give you one question where one mass is suspended by two springs and the spring one has force constant K1, force constant K2. Okay. Now, what is the time period of oscillation of this brick? That time, can I say either I have to take K1 or I have to take K2? That time I have to take equivalent K because there are two spring constants. So when more than one system comes into play, when more than one system comes into play, then you have to get equivalent. Understood?
Yes, sir.
Now, understood this much: force constant when connected in series and force constant when connected in. Okay, now listen. Now the next topic is you need to draw the graph of, listen to the topic very well. You need to draw the graph of displacement, velocity, acceleration of a body This is the name of the topic. What is the name of the topic? You need to draw the graph of displacement, velocity, and acceleration of a body starting from mean position. Make a note of the heading at least. you need to draw the graph of different velocity and acceleration of a body starting from mean position. Clear? Now listen to this. What do you know about a body starting from mean position? What are the things that you know? Tell me anything that you know about a body starting from mean position.
Displacement and acceleration is equal to
Is 0.
That is
And
at mean. Here I am saying starting from. Have we done this?
X is equal to
Sir,
A
one
sin omega
equation.
t.
Correct. We just know one thing. We know that X is equal to A sine omega t. Correct. We just know
Yes.
one thing.
Yes.
And what is that thing we know? We know that displacement X is equal to A sine omega t. We don't know anything else. We just know that displacement. But what do we need to find out? We need to find out displacement. We need to find out velocity. We need to find out acceleration graphs. But we just know one thing, but it's more than enough. Knowing one thing, I can get the other thing. From the other thing, I can get one more thing. From that, I can get everything. Okay, I just need to know one thing. Okay, now listen to this. If I know displacement is X is equal to A sine omega t, can I say I can get velocity also? Because velocity is
Yes,
nothing
sir.
but differentiation of displacement. So tell me, what is differentiation of A sine omega t? It will be d by dt of A sine omega t, correct? So tell me, what will be V equal to, tell me, what is the differentiation of A sine omega t? Tell me. A is constant, it will come out. Now differentiation of sine omega t is cos omega t into omega, because differentiation of sine something is cos something into differentiation of that something. Therefore, can I say my velocity is A omega? So tell me whether this much is clear. Let me repeat. What was my displacement? What was my displacement? X is equal to, my displacement was A sine omega. This was my displacement. What is my velocity? Velocity is nothing but my differentiation of displacement dx by dt. And what is differentiation of A sine omega t? Differentiation of A sine omega t is A omega cos omega t. Differentiation of A sine omega t is A omega cos omega t. Now, what is my acceleration? What is my acceleration? Can I say acceleration is nothing but differentiation of velocity? Can I say acceleration is nothing but differentiation of velocity? Now tell me, what is differentiation of A omega? A omega is a constant. Differentiation of cos omega t is minus sine omega t into omega. Or can I say my acceleration is minus A omega square sine omega t? Tell me if you have understood this much. Tell me if you have understood this much. All of you switch on your cam. I don't need to remind again and again. Tell me, did you understand displacement, velocity, and acceleration? Did you understand these three things?
Yes, sir.
Okay, I'm lagging. Am I lagging or am I audible clear?
Sir, in between you are lagging.
Clear, right?
Yes, sir, you are lagging.
Tell me now, is it clear? Better?
Yes, sir.
Good neighbors Wi-Fi.
graph of displacement, velocity and acceleration of a body starting from mean. Can I do it again? Can I show all three differentiation again? And I'll tell you one shortcut also. Okay. Now please look at this. X is equal to A sine omega t.
No,
Correct?
wait, we can't see anything.
Lagging again?
Yes.
Proper?
Yes, sir.
Now see here, x is equal to A sine omega t. Now, how do I get velocity? Remember this, velocity is equal to A as it is. Differentiation of sine omega t is omega cos omega t, and acceleration equal to minus A omega square sine omega t. Clear? Now listen to me carefully. Look at the final answers. Once look at the screen, look at the final answers. Can I say what is maximum displacement? Can I say maximum displacement is A? What is maximum velocity? A omega. What is maximum acceleration? A omega square. Do you understand how it came?
Yes, sir.
See, so therefore, in the formula for velocity, if A omega square comes, you should understand that is wrong. And in the formula of acceleration, if only A omega comes, you should understand that is wrong. So therefore, the way to fill acceleration, velocity, and displacement is also you should know what is maximum displacement A, what is maximum velocity A omega, and what is maximum acceleration is A omega square. Therefore, A omega square. Therefore, sine omega t, cos omega t, minus sine omega t. And you should also know that the differentiation of sine is cos and differentiation of cos is minus sine. Is it clear? Differentiation of sine is cos and differentiation of cos is minus sine. Clear? Okay.
Yes, sir.
Now, any doubt, I'll solve it. I hope everyone is clear with this.
Yes.
Yes, sir.
Now, please look at the screen. Now, let me get a table. Okay. Now, let me get a table. Now, the table that I'll get is tell me what is the value of x? I'll get disconnected. 1 minute. One minute. Getting issues with this. Look at the screen. I have made a table. In that table, I have written the value of X, V, and A. I have written the value of X, V, and A. Clear? Now I need to fill the table. So please listen to me carefully and then we will start, okay? Now first let me take X is equal to A sine omega t. Please look at the screen. Now first put omega t equal to 0. Tell me what will you get if I put omega t equal to 0?
0. 0.
If I put omega t equal 0, what is sine 0?
0.
0. Therefore, can I say my entire term will become 0?
Yes, sir.
Now, if I put omega t equal to 90, tell me what will happen to X?
1. Like A. We'll get A.
A.
I know that sine 90 is 1. Therefore, can I say my answer will be A?
Yes, sir.
Lot of disturbance. Ah, 1 minute. Better now? Can you hear me better?
Yes, sir.
Now look at the screen. I have got the answer for sine 0 and I have got the answer for sine 90, correct? If I got the answer for sine 0 and sine 90, sine 0 and sine 90, can I say I don't need to put 180, 273, 273, 60? Can you tell me why? Because I know if it is 0, A, can I continue the sequence of oscillation? Can I continue
Sir,
the sequence of
0
oscillation?
A. Yes, sir.
Therefore, 0, A, 0, minus A, 0. Can I say this is
Yes, sir.
actually, I can actually put value of 180, 273, 270 and 360. I can put it in that equation. That will be very good in maths, but very weak in common sense because I know if I get 0 and A, I can continue the sequence as 0, minus A and 0. Also, you should also notice that what value I get for 0, the same value I will get for 360 also because 0 is nothing but 360 itself, correct? Therefore, whatever value I get for 0, same thing I will get for 360 also. Therefore, can I say I have finished filling the values for X? Now, similarly, can I fill the value for V? Now, what is V equal to? A omega cos omega t. A omega cos omega t. Now put omega t equal to 0. Tell me what happens.
0.
Cos
Sir,
will
A
become 1.
omega हो जाए.
A omega.
So cos 0 will become 1. Therefore, this will become 1. Therefore, I am left with A omega. Therefore, I will get A omega.
360 also A omega.
I will do that. Now, if I put omega t equal to 90, tell me what happens.
0.
0.
Cos 90 will become 0. Cos 90 will become 0. 1 minute. Cos 90, okay? Therefore, cos 90 is 0. Therefore, can I say the whole term will be 0? Now, can you continue the sequence? A omega, 0, continue. A omega, 0, continue the sequence.
Minus A omega.
Minus A omega,
0.
0,
A omega.
A omega. Yes?
Yes, sir.
Now, can you fill for acceleration? Can you fill the same for acceleration?
Yes, sir.
Okay, now I will also fill it for you. Now, can I say if I put omega t equal to 0, can I say I put omega t equal to 0? Therefore, my entire value will be 0. And if I put omega t equal to 90, if I put omega t equal to 90, can I say my answer will be minus a omega square? Correct? Continue the sequence. What will happen? 0 minus a omega square, 0 a omega square 0. Now, please remember, once look at the screen, all of you, your value for 0 and 360 should be the same. Also, just check whether it is following the sequence of oscillation. 0, maximum 0, minimum 0, maximum 0, minimum 0, maximum.
Yes, sir.
Now, before I do the graph of this, do you know by looking at the graph, which graph did I draw? Tell me, which graph is this?
Sine.
How do you know? How do you know that this graph is a sine graph? Why not cosine?
Sir, because we can see it's alternate.
You
Yes,
can
sir.
see it is.
The
Alternate.
alternate.
इसी
Those
कारण
are
से सर
alternate.
Sir, because it is starting from 0.
Now, what is this graph?
Sine wave.
Sir, this is for acceleration.
No. Forget the topic. Generally, can I say this graph is a sine graph because it starts from 0? Any graph that starts from 0 is a sine graph. Any graph that starts from maximum or 90 is a cosine graph. Therefore, can I say this is a positive sine graph? Can I say this is a negative sine graph? But both are sine graph itself.
Yes.
Yeah.
Now,
Yes,
similarly,
sir.
can I say this is a positive cosine graph? And can I say this is a negative cosine graph? But both are cosine graphs
Yes, sir.
itself. Therefore, looking at the graph, you should get a general idea whether it is cos, sine, minus cos, minus sine. Looking at the graph, you should get an idea whether the graph is cos, sine, minus cos, or minus sine. Now, let me draw the graph of displacement. Everyone just look at the screen once. Omega t, and I'm drawing the graph of displacement, okay? Can I say the maximum value of displacement is A, minimum value of displacement is minus A. Now tell me, it is, what is it? 0, A, 0, minus A, 0. Therefore, can I say the graph will be 0, A, 0, minus A, 0. Therefore, can I say my graph of displacement will be like this? Positive sine graph. How do I know it will be a sine graph? Because I can see the equation. So make a note, draw the graph. This is a positive sine graph. Finished sine graph, that is for displacement. Now, can I draw the graph of velocity? Okay, look at the graph. I will draw the graph of velocity. Now I know maximum velocity is a omega and minimum velocity is minus a omega. Maximum velocity is a omega and minimum velocity is minus a omega. Therefore, look at this. It starts from a omega, 0, minus a omega, 0, plus a omega. Therefore, can I say the graph is something like this? This is the graph for velocity. Make a note. This is the graph for velocity. Now, can you draw the graph of acceleration? Can you draw the graph of acceleration?
Yes, sir. It will be reverse of displacement.
Tell me if you have understood this graph of acceleration that I have drawn.
Yes, sir.
0 minus a omega square, 0, a omega square, 0. This is omega t. Finish this topic.
Yes, sir.
One second, one second.
Now, the next topic is
Sir, are you writing something?
wait, I think it is. I am writing, but my connection has gone. Let me come back. Right now. We have done the graph of a particle starting from mean position. Now we have to do the graph starting from extreme position. Can you do it? I'll give you some time. Then I will do it on the. Then I'll do it on the screen. Okay, start. Did you guys get it?
Yes, sir.
Now let me tell you. Okay, let me start. Tell me, what are the things you know about the particle starting from extreme position? You just know that displacement is equal to
A cos
A.
omega t.
We know this. We already know this. From this, can we get velocity?
Yes,
What
sir.
is velocity?
Sir,
Differentiation of displacement.
Sir, X is
sine
minus.
omega t.
Yes.
Minus.
Correct, sir.
And from here, what is acceleration?
Sir, displacement is minus A cos omega t, no?
Displacement is what?
Minus A cos omega t.
No, displacement is A cos omega t. We did the derivation also.
Yes, sir. A cos omega t.
A cos omega t.
Sir, that time only you told that it's minus.
That time I told if you take minus, you have to take the other part of the graph. We are taking all silver teacups, we are taking all only. That means all positive.
Okay.
Okay. Now the first thing you should get is you should get the value of displacement, velocity, and acceleration. Did you get these three values?
Yes, sir.
Yes, sir.
You got it. Now from these values, we will have to get the table. Okay, now listen. X is equal to A cos omega t, V is equal to minus A omega sin omega t, and acceleration is equal to minus A omega square cos omega t. Correct? Now, someone is saying something? Now, can we make a table?
So done.
So I will make a table. You tell me whether you're getting it. Can anyone tell me what is the value for X 0, 90, 182, 70, 360? Anyone?
Sir, A 0 minus A 0 A.
Yes, sir.
Correct. Everyone getting this?
Yes.
Okay. Next, for B, what you're getting?
The next is 0 minus A omega 0 A omega 0.
Yes, sir.
Everyone, please confirm. Are you getting this? Or else I'll show it to you.
Yes.
Yes, sir.
Oh, sorry. Next one. What is the answer?
A omega square, 0 and
Then A omega square, then 0 and minus A omega square.
Yes, sir.
Starting will be minus A omega square. Okay, remember that. Now let me draw the graph of displacement. So it is maximum is A, minimum is minus A. Maximum is A, minimum is minus A. Therefore, it is A 0 minus A 0 A. Alright, no problem, Jainam. It is mom only, right? My also mom comes and does that. Call your mom.
હેલો સર
કરવાનો ઈ ના પાડે તો પણ કરવાનો હર વખતે તમારો હક છે કરવાનો.
થેન્ક યુ
હા.
ખીચડી ચાલશે
Ha, Jainam. Now we'll tell Jainam to do the graph now. Tell me, did you understand this graph? Now I'll tell you, in your board's exam, if this question comes, you have to mark the x-axis as omega t. Otherwise, in the board exam, they'll cut this. Okay. Otherwise, for JEE, what they will say is, I'll tell you how the question will come in JEE. Displacement of a body is given as x is equal to a sine omega t. Then which of the following is the graph for acceleration? Tell me indirectly, what do they tell you? Indirectly, what did they tell you? They said displacement of a body is a sine omega t. That means they told you body starting from mean position.
Yes.
And then you should know that what was the graph for acceleration. They'll give you 4 graphs. What will be the 4 graphs that they will tell you? The 4 graphs that they'll tell you is positive sign, positive cos, negative cos. Therefore, in that case, you should understand what is the right answer. Okay. When we do the problems, I will let you know. In fact, I will tell you one NEET in NEET exam 2019. Tell me if you can see this question. I don't know whether you can see this. Can you see this question? NEET exam 2019. Can you read it? Something. Question number 5. Can you read or you cannot read?
Can read, sir.
So we can read.
Now tell me what should be the answer. I have marked it anywhere.
Can you shift it towards right a little? Yes.
Perfect.
Understood what kind of questions they'll ask you. This
Yes,
is
sir.
2019 NEET paper. So you should know what the graph is. Now you know what is the graph for displacement. Now we should know what is the graph for velocity also. What is the graph for acceleration also. Can we start with the graph for velocity? Okay, start. Now velocity graph.
Yes, sir.
And this is omega. Clear? Okay. Now acceleration. Tell me, getting it or not?
Yes, sir.
It is not exactly cos. Okay, I have not should wrote it beautifully, but it's fine. I think I spoiled it more. Okay, fine. You know how to do it beautifully. Okay. Now listen to this. When there are two same trigonometric functions, okay, listen to me. When there are two same trigonometric functions, phase difference between them will be pi. And when there are two different trigonometric functions, phase difference between them will be pi by 2. Now, what is pi by 2? 90 degree. And what is pi? Pi is 180 degree. Therefore, can I say, listen to me, phase difference between displacement and velocity is how much? One is cos, another one is sine. Therefore, can I say the phase
Pi by
difference
2.
between pi by 2? Now, what is the phase difference between velocity and acceleration?
Pi by 2.
Pi by 2. And what is the phase difference between displacement and acceleration?
Pi.
Pi. Now look at the previous case and tell me the answer. Where the particle is starting from mean position.
So can you repeat again?
I told you this for extreme position. Can you tell me the same condition for extreme position? In the sense, I told you that if the trigonometric functions are same, then the phase difference becomes pi. And if the trigonometric functions are different, then it becomes pi by 2. Therefore, phase difference between x and v is pi by 2. Phase difference between v and a is also pi by 2. And phase difference between x and a will be pi.
Okay.
So like that, tell me for mean position. What is the phase
It's the
difference between x?
same.
It will be the same or not be the same?
It will be the same.
It will be the same. Therefore, can I say in oscillation, phase difference between displacement and velocity is pi by 2. Phase difference between velocity and acceleration is pi by 2. And phase difference between displacement and acceleration is pi. Can you make a note of these 3 points? Write down.
Yes,
Just
sir.
as conclusion, just as conclusions, write down. Conclusions from the graph. Write down. Side heading. Conclusions from the graph. Write on the side heading, conclusions from the graph.
Yes, sir.
What is the first conclusion? Phase difference between displacement and velocity is pi by 2. Phase difference between displacement and velocity is pi by 2. Phase difference between displacement and velocity is pi by 2.
Sir, can you repeat from the beginning? I actually missed it.
Yeah. So conclusions from the graph is the side heading. And I will only write it so that everyone can actually see it.
Sir, can you explain again what phase difference is?
Can you?
Can you explain again what phase difference is?
When you do EMI, you will get a better idea. But phase difference is by how much is the graph leading the other graph. By how much is, for example, what is sine 0, 0? But cos 0 is 90. Can I say that is the difference? Can I say, listen to this. At the starting point, listen to this. At the starting point, sine is minimum, but cos is maximum. Agree? So can I say at the starting point itself, cos has that much of lead over sine? Therefore, can I say after that both are periodic? Therefore, can I say in this case, if cos starts before sine and cos has a lead of pi by 2 over sine, it will constantly have that lead over sine.
Yes, sir.
But now you know displacement and acceleration are actually mirror graphs. Check. Displacement and acceleration are mirror graphs. Therefore, it will be pi 180. Same way, one is this side, one is other side. Therefore, the phase is 180. Okay. In other words, remember this, sine and cos, always cos leads sine. That I'll tell you in electromagnetic induction. But for now, you should remember that sine and cos difference is pi by 2. In that also, who is leading, who is lagging, I will tell you. And if the trigonometric function is same, it is pi, that is 180, because 180 falls on the same line. Can I say if I draw one line here? Can I say if this is a x-axis of a graph, this will be 180 and this will be 0, correct? 0 and 180 are mirror images. Can I say 0 and 180 are mirror images? Similarly, if you look at your acceleration and displacement graph, for both cases, for a particle starting from mean and for a particle starting from extreme, just notice, don't you see that acceleration is exact mirror image of displacement?
Yes, sir.
Yes, sir.
Last topic for today, and then we stop. They did not tell you, I will tell you now. The class today will be till 6:30. Okay, that is one good news for you. So we'll have last 15 minutes. And I think we have a class in the morning this week itself, 7 to 9:30. I think not tomorrow, day after tomorrow, right?
Sir, it's tomorrow.
Yes,
Tomorrow,
sir.
day after.
Tomorrow.
Sir, day after tomorrow.
Day after tomorrow.
Day after tomorrow, Krish, what are you doing?
Sorry,
हाँ.
sorry.
That is fine. That is fine. That time we'll have to do it from the module. I'm trying to do as much as possible so that when you do the module, you don't have to struggle. We can directly start with the questions from the module. Now, the last topic that I'll do today, last 14 minutes I will do damped oscillations.
Sir, damped means?
Decaying. Damped means decaying. Now listen to this. Listen to this. You know any oscillation? You gave me an example of oscillation of a swing, correct? In real life, I said all oscillating motion should be periodic. Remember, just think about it. If a person gets out of the swing, can I say swing will oscillate? But can I say gradually the oscillation amplitude will decrease? And can I say at the end it will come to rest? Therefore, can I say in real life, the oscillation will be like this? 1 minute, just look at the screen. First, it will be proper. Then slowly the amplitude will decrease.
Yes, sir. Correct.
This practical oscillation is called damped oscillation. What is damped? Damped means not perfect. In 11th standard, we had something called attenuation. Remember attenuation in electromagnetic wave. Attenuation means you decrease in strength. It decreases in strength. That is called damped signal or decayed signal. You know, decay. D-E-C-A-Y. Not our Hindi movie decay, our English decay. D-E-C-A-Y. Decayed oscillation. And you just have a formula. Damped force is equal to minus BV. Damped force is equal to minus BV. Okay, first write down side heading damped oscillation and draw this graph. That the graph whose amplitude is decreasing continuously. That graph called as damped oscillation. And the damped force is equal to minus BV. Damped force is equal to minus BV. Okay.
Sir,
Damped
what is
force.
B?
Where, listen to this. Where FD is damped force, where FD is damped force. Minus B, or what is B, is the damping constant. And what is V? V stands for velocity. That was a very good thing. Why BV is negative? Because BV is always negative. Can you tell me why it has a negative sign? Can I say because amplitude keeps decreasing, therefore it has a minus sign. What does minus indicate? It keeps losing its value. What does minus indicate? It keeps losing its value.
Sir, minus B is the constant or just B is the constant?
Only B is a constant. Only B is a
Only
constant. That is called damping constant. So in this chapter, we have two constants. One is K, which is a spring constant, and one is B, which is a damping constant. Therefore, overall force, this is the final topic. Listen to this. Finish this, written this much.
Yes,
Now
sir.
look at the next, last. Okay, okay.
Yes, sir.
Total force equation. Yeah, data, sure. Total force equation. See here, I'll just do the derivation. Listen to this. We have to get the differential equation for force. What do you have to get? Differential equation of force. What is the difference between equation and differential equation? What is the difference between equation and differential equation? The difference is equation can be any term equal to 0. Differential equation means you will have dx by dt, d square x by dt square, differentiation terms.
We have derivatives in the equation, right?
Correct. Derivatives will be there in the equation. That is called as differential equation. Now please look at the screen. Now can I say my total force in this chapter is nothing but my restoring force plus my damping force. These are the two forces I came across in this chapter. Now, can I say my total force general formula will be MA equal to restoring forces minus KX and my damping forces minus BV? Or can I write MA plus KX plus BV equal to 0? Or now I want a differential equation. Therefore, can I write M into, instead of A, can I write d square x by dt square? Can I make acceleration as differentiation term? Plus kx plus b. Can I write v as dx by dt
Yes, sir.
equal to 0? Over. This is my differential equation of a force.
Okay, sir.
Did you understand?
Sir, because acceleration is to square of displacement, right?
Double differentiation of displacement. Yes,
double.
correct. Double differentiation. You know why did I not take dv by dt? I wanted to keep differentiation with respect to x itself, means from displacement. Therefore, it is uniform. Therefore,
Yes.
my equation is uniform. I can keep acceleration as dv by dt also. No problem.
Yes. Okay.
Correct. In this is in vacuum, there will not be any damping force. Okay. In vacuum, there will not be any damping force, and vacuum F equal to Fk itself for Fr restoring force minus K. That is correct. But in practical situations, you will have damping. And because of damping, can I say my example of oscillation is no longer periodic, because periodic has to repeat in equal intervals of time. Therefore, in practical situations, but most of the times a pendulum is also proper. It is periodic. Or sewing machine is also proper. But man-made oscillations, after some time, it will come to rest. That is called damping. That is called damping. Okay. So with that, we will stop. Yes.
What were you going to tell us about lift?
About
Lift.
lift. Yes, I did. Okay. Is the damped oscillation same as damped vibration? Yes. Yes. Damped oscillation is same as damped vibration. In fact, in this chapter, I don't know whether you have done waves. We have something called as free vibrations, forced vibrations, and resonance. We will have that also in this chapter. Free vibrations, forced vibrations. Yes, your question is correct. It is same as vibration. In fact, vibratory motion is the other name for oscillatory motion. Correct. Yes, we had it in 10th. You had it in ICSE board. Had it, I think, in 10th. ICSE board had the spring motion in 10th. Not state board. We'll have a debate of state board versus ICSE versus CBSE. That will be a okay. Now let me for the people who are watching outside, class is done. We will continue in the next class. With that, I will stop the recording.